So let's start today with a little petition here. Pretty much there was this group that wanted to ban dihydrogen monoxide, so they made this website. And I'm going to ask you today what you think. But, you know, what is it? Well, it's a colorless, odorless chemical compound called dihydrogen monoxide. You know, its atomic components are found in a number of caustic, explosive, poisonous substances, such as sulfuric acid, nitroglycerin, ethyl alcohol. You know, they wrote up a whole thing about if you should be concerned about it. I like talking about the dangers a little bit. You know, you could have death due to accidental inhalation of DHMO, even in small quantities. Prolonged exposure of solid DHMO can cause severe tissue damage. You know, you can have gaseous DHMO can cause severe burns. Contamination of electrical systems often causes short circuits. You can see there's a lot of really negative things about DHMO. It's found in the biopsies of precancerous tumors and lesions. Quite a bit. What else is it used for? Well, it's used as a solvent and coolant in nuclear power plants. Members of the KKK and the NAACP both used it during rallies and marches. It's used by the Church of Scientology. It's gajillion uses here. You know, there's a link between gun violence and DHMO. You can see it goes on and on and on. They actually went around the states and they had petitions signed to ban this substance. You can see there's a long list of negative things about it. Show of hands here, who here would ban DHMO if I gave you a petition to? Okay. What is DHMO? What is it actually? What is dihydrogen monoxide? What is it?
Okay.
It can be a gas. At room temperature, it's not a gas. At room temperature, it's a liquid. What is DHMO? Dihydrogen monoxide. Dihydrogen monoxide. What is that? Oh, come on, you guys know what that is. What is that?
Water.
Water. So you just banned water, right? So today's lesson, what we're going to be learning about is how to name covalent compounds, how to go from name to formula, and formula to name. What types of elements form covalent compounds? Yep. Non-metals, excellent. Right? If you have a binary compound composed of two different elements, you're going to be looking for one thing. If it contains two nonmetals, it's a covalent compound. What does an ionic compound have? Right, a covalent compound will be two nonmetals bonded together. What about an ionic compound? Yeah? Metal and a nonmetal. That's for binary compounds. Now, what is a covalent bond? What holds it together? Well, with ionic bonds, it was the losing and gaining of electrons to get a full outer shell. What is covalent bonds?
Sharing electrons.
Sharing electrons, for the same reason, right? To get a full outer shell of electrons. Now, when you share electrons, again, our models kind of break down. I'm not really going to be testing you on that practice page too much, because our models aren't great for illustrating that sharing of electrons, but you do need to know the theory, right? You have to understand why is it that they're sharing electrons. It's to get a full outer shell, and you should have some basic idea of how many pairs of electrons they need to share in order to do so. But that is not the focus of today. Today we will be exploring covalent compounds, going from name to formula and formula to name. So first let's start with, what do you guys feel like starting with today? Name to formula or formula to name? You know what, let's start with formula to name. Let's do formula to name. So So we're going to be going from the chemical formula to the name. Now, a very simple covalent compound, the simplest of the hydrocarbons, is natural gas. Natural gas has the chemical formula CH4. Does anybody know another name for natural gas? It's methane, but we're not going to be using the organic names. We're going to be learning how to name any covalent compound using a prefix system. So, when naming, add a prefix. Actually, I'm going to specify right now. Add a Greek prefix to the names of both elements. Now, does anybody here remember their Greek prefixes? I'll give you a hint. The first one is mono. Number one is mono. What's the second one? Di. Anybody know the third one? Tri. Oh, by the way, you will have to have these memorized. The fourth one is tetra. Ooh, someone knows them well. Tetra. The fifth one? Penta. The sixth? What's that? Hexa, right? Think of your shapes, right? Pentagon, hexagon. 7. Ooh, hepta, good job. 8. You should all know this one. Stop signs are an octagon. There we go. Octa. Number 9, you probably don't know. What is it? 9's awkward. It's nona. We almost never use that. And then 10 is deca. So I do expect you to have the first 10 memorized. Okay? And again, when you do the practice, you're going to get used to using them. They'll become second nature. So, what do you think we call this compound? Well, there's one more rule I have to write down here. Just like binary ionic compounds, what did we do to the second element in a binary ionic compound? What did we add to the end? I. So we are also here going to add the suffix. Add the suffix "ide" to the second element. To the second element. Now, you know this in your common parlance, the way you talk, right? There are compounds out there that you know quite well. For example, what do you breathe out? No one's taking bio right now? Usually someone is in grade 10. You breathe in oxygen, what do you breathe out? Carbon dioxide. Right? What happens if you leave your car running in the garage and you're sitting in it? What can you die of? You might have one of these detectors in your basement. Really? Carbon monoxide. Right? So you already know this, but you'll notice something else in both of those words I chose. What did I not add to the first element? Carbon dioxide, carbon monoxide. What did I not add to the first element? Yeah, I didn't have a prefix, right? Yeah, I didn't have a prefix on the first element. So, my next and last rule when naming, if there is only one atom of the first element, do not add prefix. So what do you think we call this compound? What do you think we call this compound here? CH4. Again, it's natural gas, it's methane, but based on this naming rules I just said to you, what do you think we call this? First up, how many carbon atoms are there? There's one. But we're not going to put mono because if there's only one atom of the first element, do not add a prefix. So that's just plain old carbon. How many atoms of hydrogen are bonded to that atom of carbon? 4. So what prefix will I use? Tetra. And then what am I going to add to the suffix? Ide. Right, that's tetrahydride. All one word. So again, you can see right away that this is not a hard skill compared to ionic bonding. And it's even easier going from name to formula. Why is it even easier? It's super easy. It should be free marks. What's the only thing you have to have memorized in order to be able to go from a name to a formula? The prefixes, right? The prefixes tell you how many of each atom is in your bond, right? So going from name to formula for covalent compounds is super, super easy. But let's do a couple more examples because this is the harder of the two skills. So let's do, I don't know, let's just make stuff up. Let's say this. I'm just making things up. I'm not sure if it's real compounds or not, but it doesn't need to be. What do you think we're going to call this one here? First up, how many atoms of nitrogen do we have? 2. So which prefix are we going to use? Di. So this is going to be dinitrogen. Right? The only time we do not put a prefix is if there is one of them. And then how many oxygens do we have? 5, so we're going to be using penta. So this is going to be pent. Really, it's pentoxide, but I'm not going to confuse you guys with that. We're going to put pentaoxide. Just to make things simple. Technically, it should probably be pentoxide, but that's fine. Now, what about this one? By the way, that's propane. So if you barbecued in the summer at all, that is the chemical formula for propane gas. What are we going to call that one? Yep. Yes. Excellent. Tricarbon octahydride. So if you really want to confuse the clerk next time you go pick up some propane, just ask them for the tricarbon octahydride. Their minds will explode. So, going from formula to name is not too hard as long as you remember you got to add prefixes to both your first and second element, with the one exception being if there's only one of that first element. Now, you also need to add the suffix "ide" to everything. Let's just do one more example here, because for some reason all of you didn't realize that we breathed this out. What is this? Yeah, it's carbon dioxide. Why isn't it monocarbon dioxide? Really, scientists just thought it sounded dumb. So we don't add, again, the prefix to the first element if there's only one atom of that element in your covalent compound. Alright, so you have lots of practice to do on this, and please do some of that practice tonight. Now moving on, let's go from name to formula. Let's go from name to formula. Now going from name to formula is pretty straightforward. It's easy because the Greek prefixes tell you, right, they tell you how many of each atom is in the bond, or in the compound. Probably doesn't even need to be said. So really, really, really straightforward as long as you remember your prefixes. So for example, if I said to you, tetracarbon decahydride. Oh, by the way, I'm only going to be giving you binary covalent compounds. Covalent compounds are a huge family of compounds that, all of our complex molecules in our body are covalent compounds. They can be massively long with tons of different elements combined together. We are not going to be looking at that. We're keeping it really simple in grade 10. We are just going to be doing binary covalent compounds. So you're only ever going to see two nonmetals bonded together. Now, what is the chemical formula for this one here? Yep. That's right. So again, we just look at our prefixes. Tetra, that's 4. We have 4 carbons. What is the deca? 10. So that's going to be H10. That's butane, by the way. That's what's in your lighters. What if I gave you, say, nitrogen triiodide? By the way, this is a fun one. It's a little contact explosive. I had a teacher in high school that messed with us. He used to have a carpet right in front of the door, and he'd throw nitrogen triiodide under the carpet, and when you stepped on it, it would crackle and pop and blow up. It's kind of cool. Maybe slightly dangerous, but I don't know. Nitrogen triiodide. What is that one? Yeah. Ni3. Excellent. Now, why did you not say like N2 or N3 or N4? What's missing there? The prefix. And again, the only time we do not list the prefix is if it is mono, right? If it's mono on the first element, right, if there's one of that first element, we don't put a prefix. Let's do one more example here. Let's say you had this is going to be made up completely, but that's fine. We're going to say diphosphorus heptachloride. diphosphorus heptachloride. Let's give me the formula for this one. Excellent. P2Cl7. Again, di is the prefix for 2. We have 2 phosphoruses. Hepta is the prefix for 7. We have 7 chlorides. So I'll repeat myself again, as long as you have these memorized, covalent compounds should be a breeze for you. As a result, they actually don't make up a very large part of your unit test in this unit. Most of the skills that you will be practicing moving forward is involved again in ionic bonding. So ionic bonding is essential for doing the next thing, which is going to be going from word equation to chemical equation to word equation. So we're going to be now actually creating the recipes of chemistry. And hopefully we'll have time to do a couple labs as well. Anyone have any questions? Okay, get to work.